Okay guys, here are the things we need. The first thing we need is the usual breadboard, and I have 5 LEDs in red color, the 2-pinned one, and I have the power bank. I am using this to power up my Arduino board, and I have 220 ohm resistors, 5 resistors with me, and I have the jumper connectors, the usual jumper connectors I am using, and I have the USB cable to connect my Arduino board, and I have this Arduino board, the usual Uno board, the original one. The first thing we need to do is getting these LEDs connected into my circuit. In LED I have 2 pins, the shorter one is negative and the longer one is positive, so the anode and cathode. And I am putting this longer one to my Arduino board to give inputs, and I am connecting this shorter one, the negative one, into the ground pin in the Arduino board. So how am I going to make the connection? It's very simple. So you have this 2 sections with where you can connect to positive and negative. I am taking this one as the negative one. So I am going to widen up this a little bit, and I am going to hold this negative one in this pin, the positive one in this column, like this. So what I can ultimately do is connecting a jumper wire right here and connecting that as an input into my Arduino board. Very simple. So I'm going to connect the rest of things in the same manner. So here are my LEDs, they're connected perfectly. So all the negatives are connected to this series right here, and all the positives are connected into each of these series, where I can connect a small jumper wire and I can get them connected. So let's take a small jumper wire to get my ground pin connected. So I am using this white color jumper wire right here as my ground pin. So ground pin goes with this column, so I'm going to connect it right here. Very simple. So this end connects all these ground pins together, and this end connects it into my Arduino board. That's very simple. So next thing I need to do is making these things to get inputs from the Arduino board, where I declare the pins at output. So the board gives outputs and these guys are getting inputs to light up. So before we give any current to these LEDs, I already told you that these LEDs right here are working with 3.7 volts current. What I'm getting from Arduino board is 5 volts, so I need to reduce that to 3.7 volts to give each of these LEDs. So how am I going to do it? I'm going to grab my resistors. So these resistors are 220 ohms. Each one of these is lowering that 5 volt current into 3.7, so these LEDs won't burn up. So how to make that connection? It's very simple. As you can see here, there is the divider. So from this column there is no connection to this column after the divider. So what I'm going to do, I'm going to grab my resistor. I already bent it up so I can connect it with the board. So I'm going to hold it right here and the connection is done. As you can see, it's very simple. So I'm going to give it a closer look. See, right, this pin is connected to this pin, and through the resistor it is connected to this series. So from anywhere of these 5 holes I can get a connection to my Arduino board to give outputs, so this LED can take it as an input. So I'm going to do the same thing for the rest of LEDs as well. Okay guys, as you can see, it's perfectly done. You have the LEDs lined up right here and you have the resistors lined up right here, and each LED is now connecting through this resistor, so they are getting 3.7 volts always and they won't burn up. So next thing is connecting the jumper wires. Now connecting jumper wires, there I took a set of jumper wires, so I didn't kind of tear them off, and I have 5 connections already. As you can see, this 1 2 3 4 and 5, and each one has a different color, so it's very easy for me to identify which LED goes for which. So I'm going to connect them from right side to left side, starting from this black color one. So the first one is connected to black color, second one is connected to this white color, and third one is gray, fourth one is purple, and the last one is blue. So let's make the connections like this. See, as you can see, it's a perfect connection. See, everything is lined up now, so only thing I need to do is connecting this thing with my Arduino board. So let's see how that happens. Here I have my Arduino board right here. So I'm going to use these pins. As you can see, there are different number of pins I can use, starting from 0 to 13. There are digital pins, so they give 5-volt outputs. I'm not going to use this 0 and 1. I'm going to start by 2. So starting from 2, I'm going to use second pin, third pin, fourth pin, fifth pin and sixth pin to connect my LEDs. And I have a ground pin right here, so I can either use that, or in the power section right here I have another 2 ground pins, so I can use any of those. So I would like to connect this ground pin this time. So starting from 2, I'm going to connect these LEDs to starting from black to blue, from pin 2 to pin 6. So starting from second pin is the black one, and third pin is the white one, gray color one is the fourth one, purple one is the fifth one, and I have sixth one connected to the blue one. So starting from this right side is my second pin, and the left side is my sixth pin. So this is how the connection is made, and I need to connect this ground pin, which is the white color one. Already I made that, so I'm going to connect that right here. So that's it, the connection is done. So this is my complete circuit right here. So next thing I'm going to do is making the program to light these guys up in the Knight Rider method. So let's see how to do it. Okay, we are going to make the code. So first of all, we have the 2 structures, the void setup and void loop, the usual 2 structures. And before everything, I'm going to make something very easy. Now I have worked with 5 LEDs right there, and these LEDs are connected to pin 2, pin 3, pin 4, pin 5 and pin 6. But the problem is, every time if I have to work with these pin numbers, it's really difficult. So I would like to call it from the left side to right side as LED1, LED2, LED3, LED4 and LED5. So what I ultimately want is light up LED1 and then turn it off, then light up LED2 and keep it a while, then turn it off, light up LED3 and then 4, then 5, and then starting from the right side to left side, then I need to light up LED 5, then 4, then 3, then 2, then 1. This is the order, and it is going to switch between the directions. So first of all, I need to name LEDs in a pretty easy way where I can simply understand which LED is I'm working with. So I'm going to use this simple code which is called hashtag define. Now hashtag define can be used to configure or define pins into some considerable names, so you don't have to work with pin numbers. Instead you can work with name. That's super easy. So I'm going to call LED1, and LED1 is assigned to pin 6, so I'm going to call it pin 6. Now in the same way I need to do with the rest of LEDs, so I'm not going to type everything. I'm going to copy this CTRL C, and then I'm going to paste this 5 times CTRL V. 1 2 3 4, there I got 5. Yep. And next thing, I need to change the names into LED2 and LED3 There I get LED 4, and lastly I have LED 5. And as I told you, LED 5 is attached to pin 2. So starting from 6, 6, 5, 4, 3, 2, those are the pins I use. So I'm going to give 5, 4, 3, and lastly 2. So I don't have to use 2, 3, 4, 5, 6 anymore in my code. I can call them LED1, which resonates with me very easy. And next thing, I need to do the setup. So within the setup, what I'm going to do is declaring the pins as output pins. So I have that usual command pin mode. We have already discussed how to work with this pin mode. So pin mode, within I need to use the pin number usually, but this time it's a different story. I'm going to use this name. So I'm going to say LED1, and LED1 comma is output, so within capitals output. That's it. So I have 5 LEDs to go. So I'm going to simply keep this semicolon to end the code, and I'm going to copy this phrase, very easy, and then up to 4 times I'm going to replace this. 1, 2, 3, 4, altogether I have 5 options. And next thing, I need to define this LED. So LED2 is output now, LED3 is output now, LED4 is an output now, and LED5 is also an output. So my setup procedure is done. So next thing I need to work with is the loop. So working with loop, in the sense, I need to emphasize this problem with most of Knight Rider circuits. I have seen many videos in YouTube that Knight Rider circuit is being taught, but they are too artificial, because I am a very big fan of this Knight Rider and Mike's car. And next thing happening, when I see that light pattern, it moves from left side to right side, and then right side to left side, and there is a small gap, and then again it moves. It's like in between lights you have a small time period, but in between each cycle you have a bigger time period. So that is the realistic Knight Rider work, and that part is missing in most of Knight Rider circuits in YouTube. So I'm going to cover up that part. So I need 2 time gaps. I already told you that keeping time gaps in numerical way, it's going to be a little harder. So I'm going to declare 2 variables to hold those time variables. So I'm going to say int, and int I am giving the time, and this time I'm declaring right here is the time gap between 2 bulbs. So this bulb time gap, I'm going to keep it equal to 80. Believe me, I tried with lot of values, and these were the values mostly resonated with my circuit. So you can see in the output session how it works. In between each bulb I need 80 milliseconds of gap, and that would be ideal. When you try more LEDs, it will be super fun, it will be super fascinating. So in between lights I'm going to keep 80, and next thing I need another variable which holds the time gap between each cycle. So that I'm going to call as ST, and ST is start time gap, and I'm going to give a value of 300 milliseconds. Now this 380, they resonate wonderfully. You can see in the output, when I show you the output after we upload this sketch into our circuit, it's super fascinating, it's wonderful guys. And you can try different values as you want, like you can try 50 and then some other value like 200 here, and you can make it little faster. I tried to make it closer, perfectly closer to the original Knight Rider circuit, and these were the values resonated with me. So next thing is I'm going to make that light pattern into 2 phrases. The first phrase covers traveling the light from left side to right side, and the second phrase covers traveling the light from right side to left side. So I'm going to add the comment. Adding comment is very easy, double slash, and I'm going to call it first part. This won't be considered as a code by the compiler, so it will be for our reference, and it's very easy way to do programming without messing with. So next thing is lighting up the first light. So I'm going to write digital right. Observe the capitals wherever the capitals are. We have gone through that earlier. And next thing I need is to light up the first LED. So I'm saying LED 1 comma high. So high in close brackets, and that's it. So the first LED now lights up, and there is a small time gap. And what is the time gap? I need a delay. We already worked with it. So inside delay, I'm not going to type any values. I have these variables very easy. So I'm going to say time, and that's it. So the first LED lights up and it waits for the gap, and next thing I need to do is turn this guy off and turn on the LED 2 immediately after turning off the LED 1. So let's get this thing copied because I'm very lazy at typing things. Here we go. So LED 1 is now low. That's it. And I need to make LED 2 high. So here I have LED 2 high. So it lights up the first LED, then waits for the 80-second time gap I gave, and it turns off the LED 1 and immediately it turns on LED 2. Next thing to happen is turning off LED 2 as usual. So let's turn that off. Here I go. I have the delay time. It waits for the considerable time, and next thing I need to turn this LED 2 low and LED 3 high. Now as you can see, this phrase is going to be repeated until LED 5. So I'm going to copy that phrase and I'm going to paste it, and here I'm going to make this LED 2. So the LED 2 is turned off now, and LED 3 should be lighted up, so I'm going to replace it as 3. Very simple. And next thing I'm going to have another session copied, and here LED 3 is turned off and LED 4 is lighted up. Cool, huh? And next thing, the last thing I need to do is turning off LED 4. So I turned off and I'm turning on LED 5. Very simple, simple as that. So with that done, my first part is over. So the second part is yet to happen. So I'm going to add a double column and say second part. So I can simply understand what is the first part and what is the second part. And during the second part, the right opposite or the right reversing thing should happen, as you can see here. So how am I going to do it? Am I going to type everything? No. So I'm going to copy this and I'm going to paste this. Very simple. But this time I need to configure with the value. So I don't need this part at the beginning because LED 5 is already lit, so I don't have to light it up again. So I'm going to remove that part. Very simple. And starting from here, I'm going to lower LED 5 and I'm going to light up LED 4. And then I'm going to lower LED 4 and going to light up LED 3, and it's already there, nice for me. And next thing, I'm going to make LED 3 low and I'm going to make LED 2 high. And next thing, I'm going to lower LED 2 and I'm going to light up LED 1. So there, most of my code is done. Now next problem and situation is this part is not turned off. So where did I turn it on? Here. So I'm going to copy that part, paste it right here, and this time I'm going to keep it low. That's it. My code is mostly done. So the LED 1 lights up, then it turns off. LED 2 lights up, turns off. 3 lights up, turns off. 4 lights up, turns off, and 5 lights up, then turns off. Then right opposite happens. 5 to 4, 4 to 3, 3 to 2, 2 to 1, and 1 is now turned off. Now 90% of our work is done. But next thing is we need to think about the next cycle. I already told you that in actual Knight Rider circuit there is a small time gap larger than the time gap between the bulbs is available between the cycles. So that is given by this ST variable. So this
variable carrying time is not what I need. It's a more gap, which is st. So with this, what is happening from the beginning, it is going to follow 80 milliseconds of gap, but at the end of this cycle to the next cycle, it is going to follow 300 milliseconds of a gap, and that's going to give me a fine smooth LED perfect Knight Rider circuit like in Mike's car. And I'm going to upload this sketch in my Arduino board, and let's see how the output will be.
Bingo! We are done with the connection, and as you can see, it's perfectly working as the same Knight Rider circuit in Mike's car. As you can see in the time gaps, in between each LED you have 80 milliseconds of gap, and at the beginning you have like more milliseconds. It's like 300 milliseconds of gap. So in the actual teledrama, you may have seen the light travels from this side to this side, and there is a small waiting, and then again it happens. So this is perfectly working in the same manner. These are the values I came up with. Different values I have inserted. So in between bulbs I have kept a timer with 80 milliseconds, and in between each cycle I kept a timer of 300 milliseconds. So it works perfect. So this thing, if you can make it in a small PCB, will perfectly fit into your robot whenever it detects some obstacles, or whenever it kind of detect some colors. It will show a fancy signal to the audience that it's searching for things. So it's like a scanning bar. It fits perfect, and it feels so nice to have such a thing in a car robot. Something I made like this. So as you can see, this is my board, and when this thing fits right here, you can see the difference. It works wonderful, right? It's so nice. If I can make it into a PCB, and if I place it whenever this guy turns here and there and detects something, it will show a Knight Rider movement. That's super cool. So that's it for today.